There, now you got it. It's time for volume. I know you're so excited. So we are going to look at volume formulas today. Yay. All right, so again, this is way simpler than surface area. So you're going to absolutely love this. So first, we are going to take a look at three different solids. We've got the rectangular prism, the triangular prism, and the cylinder. So we've got this rectangular prism, this rectangular prism. We've got three rectangular prisms, okay? And it's all the same, okay? And basically all of these, triangular prism, cylinder, and all of the rectangular prisms, it's all the same formula. Volume equals the area of the base times the height. That's all you gotta remember. Volume equals the area of the base times the height, okay? And volume, we've talked about previously. Basically, the difference is the surface area is the area of the flattened net. So it's two-dimensional. Volume is how much stuff is inside of the solid, okay? So volume is three-dimensional. Okay, and so you can think that can be like a shortcut, like that's when you put the little 3. Okay, it's how much stuff is inside. Basically, it's how many 1 by 1 by 1 unit cubes are inside of this thing. Okay, for area, it's how many 1 by 1 squares there are. So that's just two-dimensional. Okay, all right. So if I look at this rectangular prism, okay, my base is going to be a rectangle, and in a rectangular prism, it doesn't matter if I call this one the base or which one I call the base. Okay, I'm gonna call this piece the base down here. Okay, and I'm gonna tell you that this rectangular prism, okay, and these numbers are kind of made up just so that you know, just to kind of show this. Okay, but on this rectangular prism, we're gonna say this is 5 centimeters. This is 6, and this is 2. Okay, so this is a 5 by 6 by 2. Okay, so then this base, the thing that I said was the base, is going to be 5 by 2. Okay, so the area of the base is what? Yes, 5 times 2, which is 10. Okay, so my area of the base is going to be by 5 times 2 times the height, and the height is 6. So now I'm just going to go 5 times 2 times 6, which gives us 60 centimeters cubed. And that is all you have to do to find the volume of a rectangular prism. That's it. That's all you got to do. I'm not lying to you. That's it. Done. Next, we're going to look at a triangular prism. Okay, but again, it's the same thing. It's just volume is equal to the area of the base times the height. Okay, whatever that base is. And in a triangular prism, the base is a triangle. Okay, so I'm just gonna make up some numbers again. I'm gonna say that the base of the triangle is 6, and I'm going to say that the height is 4. So the base, the whole base is 6 and the height is 4. And then the height of the triangular prism is whatever connects the two bases. So whatever is connecting the two triangles, okay? So I'm gonna say that this is 8. All right, so 8. That is the height of the triangular prism. We're finding the area of the base, okay? And this area of this base is a triangle. So it's half times base, which is 6, times height, which is 4. Okay, that gives us the area of the base. So this right here, that's my capital letter B. Okay, that's my area of the base. Okay, and now I'm going to multiply that by the height. And I said the height, or what connects the two bases, is 8. So half times 6 times 4, or half of 24, is 12. And 12 times 8 is, I heard it, 96, good. 96 cubic centimeters. And that is the volume of my triangular prism. And that's it. That's done. You got it. Easy. All right, so next is the cylinder. I have 2 of them here. This is my can of SpaghettiOs, or whatever it is that you might eat from a can. So I might use this one, it'll be easier to write on. Okay, so I am going to say that my radius is 10 millimeters. 10. That's my radius. 10. Okay? And then the only other figure that we have on a cylinder is the height. And again, the height connects the two bases, and this looks like this height is 25 millimeters. 25 millimeters. All right, so to find our volume of a cylinder, we're going to use the same thing. The volume is equal to area of the base times the height. Okay, and in this case, the area of the base is a circle, so we need to use the circle formula. So basically the volume of a cylinder, and you don't have to memorize this, you just have to remember that it's area of the base times the height. We still have only been using one formula, V equals BH, you can remember that. Okay, but in this case the area of the base is a circle, so pi r squared. Okay, so in this particular cylinder, we've got pi times the radius squared, okay? And the radius is 10, so pi times 10 squared times the height, and I said the height was 25. Okay, so we've got volume's equal to pi times 100 times 25, okay? So that would be 2500 pi. Okay, if we wanted to write this in terms of pi, we would just go 2500, that pi was poor. We would just say 2500 pi, and then whatever the units are cubed, and in this case it's millimeters. So we could just write it like this if it says in terms of pi. Otherwise, we would need to multiply by pi if it tells you like to round to the nearest tenth. So I'm just gonna ask Siri real quick. So that was a fail there. Apparently Siri kicks you out if you try to ask her a question at no longer videos. So anyway, I thought that would just be part of my video, but I lied. Okay, so the volume of this cylinder is approximately 7,853.98 cubic millimeters. But again, this one is, this is an exact answer because it's in terms of pi. This one we rounded, so it just kind of depends on what the directions are asking you for. Okay, but again, same formula. All right, and then just gonna show you one more here. This is a this base is a pentagon. Okay, but it's still a prism. Okay, it still has two parallel bases that are the same. So basically, we're gonna use the same thing. We're gonna find the area of the base, so the area of a pentagon, and then we're just gonna multiply it by the height. That's all you have to do. Okay, so any sort of prism or cylinder, you use the same formula. It's just volume is equal to the area of the base times the height. Okay, and then there's just one more formula that you need to remember. This formula right here. Volume equals 1/3 times the base times the height, okay? Or base times height divided by 3. And that is for a cone or in any sort of pyramid, okay? All right, so that's just one other one that you need to remember, okay? And before we do our calculations, I'm just gonna, experiment and make sure that this formula actually works, okay? So we're just gonna test this out, all right? So I have a couple of things that I am going to use. All right, so these pieces, they have, all right, so this is a circle, this is a circle, same base, same size, okay? The other thing, they're the same height. Same height, all right? Also, with this one, we've got a square for the base on both of them. It's the same square, same size. They have the same height also. So since they have the same base and the same height, I'm just going to make sure that this pyramid, can hold 1/3 of what this can hold. All right, so we're just gonna see what happens. This is an experiment. I should have a lab coat or something, I think. It's an experiment and all. You know what, I'm gonna just go see if I can find a lab coat. Pardon me. I will return. Okay, so this was the closest I could find that this is my lab coat. Okay, so, you know what? This could get dangerous. I better put on my goggles. I think this is probably for someone smaller than me. Whew. I did not try this on before this. Yeah, this is definitely made for someone quite a bit smaller than me. It's like pushing my ears down. Huh, interesting. Okay, all right, well, but safety first. Gotta be safe, always gotta be safe. All right, okay, so, okay, I think it's gonna pull my ear off. Whew, okay, all right, but again, we always gotta be safe. All right, so I'm gonna take this pyramid. It's like hard to breathe. But somehow this is safer. Okay, all right, so what I'm gonna do is I have this nice little volume enhancing formula. I mixed up this formula of stuff. It's volume enhancing formula, and we will see how it works. All right, so here's my rectangular prism, and I'm just gonna pour this volume enhancing this volume enhancing formula liquid into my pyramid. Woo! Okay. Uh-oh. Woo! Doesn't matter that it spilled just a little bit. Okay, I got it one. All right, so there's one. Does that look like it's about 1/3 full? Yeah, I think so. I think that looks about right. That's what we're hoping for, right? Because we think that this is 1/3. All right, let's keep going. Let's see if 3 of these would fill it. Ooh. All right, I filled it twice. Let's see what happens here. Okay, can I do it? All right, excellent. Ooh, look at that. All right, does that look like it's about 2/3 full? I think perhaps. All right, and then one more time. Okay, last one. Let's see what happens. Hopefully it doesn't overflow. Okay, if this doesn't work, then the formula's a lie. All right, what do you think? Is it gonna work? Let's find out. Oh, look at that. It's like right at the top. Wow, guys. this is huge. So this formula is true. This pyramid is actually 1/3 of the volume of the rectangular prism. Wow, mind blown. Oh my goodness. Okay, I have to get this thing off. Oh, whew, I am glad that we are all still safe, but ooh, that was tough. Okay, so we got that one done. Now let's see if it works for the cone as well, and let's do this one differently. I think I'm just gonna go the other direction. I'm gonna fill up the cylinder and then see if I can fill the cone up 3 times. We'll go backwards and just, test it out, make sure that this is a foolproof formula and, it works. You're right. Safety first. Safety first. All right. You guys all right? I need to be safe. I appreciate that you care about me so much. Okay, let's see how this works. Oh my goodness, I just pulled my nose. I'm sorry if you just saw my nostrils. That's weird. That's very strange. Just see if it works. Okay, so here's my cylinder. Okay, and we are going to prove, we're going to prove, you guys love proof, that this cone is 1/3 of this cylinder. Okay, and I'm going to do my best. This is going to be a little tough here. Moment of truth. Can we do it? Is it gonna work? Oh, it's just about perfect. Look at that. Okay, so 3 times. All right, so if the cylinder is 3 times the cone, then that means the cone is 1/3 of the cylinder, which is what we were trying to prove. All right, guys, so we're gonna find the volume of this cone. All right, this radius, I'm gonna say is 3, and then the slant height, I'm gonna say is 5. That's the slant height. If you look at this, we know the slant height, but we need to know the height. Right? And what kind of figure do you see that makes the height and the slant height and the radius? Yes, it's a right triangle. So we need to know this. I'm just going to put a little X there. We need to know X. We know the base and we know the hypotenuse. We need to know that. What are we going to use? I heard it. Good job, guys. We're going to use the Pythagorean theorem. So we're going to go 3 squared plus x squared equals 5 squared. And then we're just going to solve for x. We're going to subtract 9. We get x squared equals 16 and x equals 4. Okay, so that x is our actual height. Okay, so from the point down to the center of the circle, that is the height of our cone. Okay, so we're going to go 1/3. Now I'm going to go back up here with this formula. 1/3 times the area of the base, and the base is a circle. Okay, so it's 1/3 times pi times r squared, or 3 squared, okay, because the base is a circle, or pi r squared, so 1/3 times pi r squared times the height. And I said that the height is 4, so times 4. Okay, so remember this base, that's pi r squared. Okay, so 1/3 times pi times 9, or 1/3 times pi times 9 times 4. Okay, and so you can multiply 1/3 times 9, which is 3, times 4, which is 12, or you could say 1/3 of 36 is 12. But our answer is 12 pi and whatever it is, centimeters cubed. That is my volume. All right, so we've got a pyramid now. Okay, this is the last one, and then that's it. Okay, and this one is a square pyramid. Okay, so these dimensions are the same, and I'm gonna say that it's a 6 by 6. Okay, and then I'm gonna give you the height this time. Okay, I'll be super nice. And I'm gonna say that the height is 8. Is 1/3 times the area of the base, and the base is 6 by 6. Okay, so 1/3 times 36 times the height, and the height is 8. Okay, so 1/3 of 36 is 12 times 8, which is 96. Okay, so 96 centimeters cubed. That's the volume of this pyramid. Good job, guys! You got this volume thing. Excellent! Are you ready to pump up the volume?